Whence comes this mighty giant called steel? Steel is the result of man's ingenuity in utilizing one of nature's greatest gifts, iron ore, which primarily is the metal iron firmly combined with the gas oxygen. The first iron used by man was no doubt meteoric iron that had fallen from the sky, such as this specimen. It was used mostly for ornaments. The early Egyptians called it metal from heaven. No one knows definitely how iron was made in prehistoric times, but to see how it might have been done, let's take a look at one of the known primitive methods. A crude furnace was made of clay with the top open. Through the top, the furnace was charged with charcoal. To cause the fire to burn more freely, an air blast was provided by bellows made of flexible animal skins. Elevating the upper part of the bag permitted air to enter through a hole in the top. After it was inflated, pressing down on it forced air into the furnace through hollow wooden tubes. By operating the two bellows alternately, an air blast was maintained. When the furnace had been heated sufficiently, iron ore was scattered over the burning charcoal. Inside the furnace, under the influence of high heat, gases from the glowing charcoal, which is mostly carbon, gradually drew oxygen from the iron ore, leaving metallic iron. After the fire had been forced for several hours, the operator dragged out a lump of spongy metal. This was vigorously hammered to remove slag or cinder and get the iron into compact, usable form. In time, it was discovered that by reheating the hammered iron, it could be worked more easily. But occasionally, the repeated reheating and hammering produced unexpected results. Sometimes the resulting metal, when cold, instead of being soft and malleable, broke into pieces when hammered. During the heating in the charcoal, the iron had absorbed so much carbon that it became hard and brittle when cold. On other rare occasions, the result was a remarkable material, neither soft nor brittle. It had entirely different properties. It was hard and tough, yet malleable. What happened was that during the heating of the iron in the charcoal and subsequent hammering, the iron absorbed the correct amount of carbon from the charcoal and became a form of steel. It should be borne in mind that in this primitive process, the iron was not completely melted, as in the usual modern making of steel. From available information, it appears that the Chinese were the first people to develop a method of completely melting iron in large quantities. The exact method used is not definitely known. Numerous Chinese iron castings, all more than 1,000 years old, have been found, including this iron stove, which was cast at least 1,700 years ago. And here is a hollow image of a huge lion about 20 feet high, cast in 953 AD. It was not until the 14th century that European iron makers started to melt iron in quantity, by developing a type of furnace shown here in model form. This furnace was erected in 1761 at Hopewell, Pennsylvania, in what is now a National Historic Site administered by the National Park Service. Iron produced was cast into cannon and other war material used by George Washington's Continental troops. The furnace, some 35 feet high, was charged through this open port at the top. the charge consisting of charcoal, iron ore, and limestone was conveyed to the top of the furnace in baskets on carts, such as this. The limestone was used to remove impurities from the iron. A blast of air was forced into the furnace at the bottom through an air duct or tweer. Power for the air blast was supplied by a water wheel operating huge air pumps set above it. Through a hole in the casting arch, the iron was tapped twice a day, and about 25 tons a week was produced. The molten iron was run into molds. Because of a fancied resemblance to a sow and her suckling pigs, this was called pig iron. However, most of the iron used during colonial days was being produced by processes very similar to the primitive method of heating iron ore in a charcoal fire, turning out only about 2 to 6 tons a week. And steel was still being made by reheating the iron in contact with charcoal. Not until 1856 was an inexpensive method developed of converting blast furnace molten iron into steel on a quantity basis by removing the excess carbon. This was accomplished by the development of an air blast converter, of which this is one of the earliest models. This revolutionary development made possible for the first time the production of steel on an inexpensive quantity basis and paved the way for the great steel age. In the modern Bessemer process, the converter is tilted on its side and hot metal from a blast furnace is poured into it through the open top. This converter is then tilted upward and a continuous blast of air is forced through holes in the bottom of the converter up through the molten metal. The oxygen in the air blast combines with the carbon in the molten iron, forming a gas which shoots skyward with blazing brilliance. The Siemens Martin open hearth furnace came into use a few years after the Bessemer converter. This type of furnace now produces 90% of all steel made. The modern manufacture of steel begins with the procurement of raw materials. Most of the #1 basic material, iron ore, is found near the surface of the earth, and open pit mining methods are used. Giant shovels scoop up huge bites of ore. Some of these shovels have a capacity of 15 tons. The trucks are quickly loaded and the ore is on its way. In underground mining, shafts are sunk far into the earth, sometimes as deep as 3,000 feet. At various levels, passageways are driven into the ore body, which is blasted to loosen the ore. After the blasting, mechanical scrapers deposit the ore into chutes, from which it drops into cars. These cars move over a pit and automatically dump into a chute which conveys the ore to a skip, in which it's hoisted to the surface, and into railway cars which convey the ore to the loading dock. Arriving at the loading dock, the ore is dumped into pockets for transfer to Great Lakes freighters. The average loading time is about 6 hours. The average load about 10,000 tons. Great limestone deposits that millions of years ago were the bed of an inland sea give up the second basic material used in modern steel making, limestone. The entire wall of the quarry has been shattered by blasting to permit removal of dense, hard material. An electric shovel swings into action. These cars are carrying 600 tons of calcium carbonate, or stone as it's termed in the industry. With the push of a lever, a carload of stone is dumped. Plunging into a huge crusher of cast steel, the complete unit weighs 750,000 pounds. The crushed stone is deposited in huge storage piles, 60 feet high and several hundred feet long. Beneath the storage piles are underground tunnels through which the stone is conveyed to the loading shuttle, which carries 2,500 tons per hour. After hundreds of miles of open water travel, cargoes of iron ore, coal, and limestone arrive at the steel plant and are quickly unloaded. Speed is essential to get the boats away quickly for another load. Train loads of the third basic material, bituminous or soft coal, arrive at the plant where it's converted into coke. This takes the place of the charcoal previously used as fuel. After the coal has been crushed, it's heated in these huge ovens until the moisture and the volatile matter have been driven off. After various byproducts have been extracted from the volatile matter, the gas remaining is used as fuel. After 16 to 24 hours, the red-hot coke is pushed out. It's now 91 to 92% carbon. The first step in making steel takes place in the blast furnace. Here the oxygen and impurities are removed from the ore and the iron reduced to a liquid.